Okay, let's continue on in our vectors unit. In the previous lesson, we learned how to break down a vector into its components. And in this lesson, we're going to learn how to add two vectors together and find the resultant. Having this knowledge is going to help us solve real life applications, which we'll get to one at the end of this lesson, and even further towards the end of this chapter when we get to just word problems. Knowing how to add, then in our next lesson, we're going to learn how to subtract vectors. That'll all come in handy. All right, so I want to start things off by just showing you the same set of formulas that we've been working with, just with different variables showing our vectors. Typically, vectors are represented by the letters U and V, and the resultant as R. And don't be confused by the straight line brackets there. All that's insinuating is the absolute value, meaning you're taking only the vectors to only be positive. Regardless of whether they're negative or not, you make them positive. Okay? And the little arrow above the variables there, U and V and R, just represents the fact that they're a vector. Okay, so there's two different methods of adding vectors. One is called the head-to-tail method. The other is called the tail-to-tail method. Okay, in the head-to-tail method, it's kind of exactly what it implies, is you're going to draw these. If I have the vectors U and V here and I wanted to find the resultant, I'm going to draw these vectors head to tail. And what I mean by that is you're simply going to take your U vector. Okay, so let's assume that this is supposed to be U plus V. Okay, so you're going to take your U vector and then draw your V at the head of our U vector. So if this is U here, this is now our V. So we essentially took this vector and just moved its location, okay, at the head of our U vector. And our resultant vector, as you probably imagine, closes this triangle. Okay, now you're probably wondering, which way do you draw the arrow? Okay, which way do you draw the arrow for the resultant? Well, the resultant always goes from the starting point, let's call this our starting point, and it goes towards the end point. Let's call this our end point. So the arrow for our resultant would be right there, towards our end point. Okay, so if I had to draw the resultant, this is what I would draw. This is what it would look like right there. Okay, that is our resultant if we were to add U plus V there. Okay, using the tail-to-tail method, again, it's exactly what it implies. You're going to draw these vectors tail to tail. So let's say again, okay, you have these vectors. I'm just going to move them down here. Okay, so let's say you, once again, oh, and my line didn't come with it. Okay, so suppose you had the two vectors here again. To draw them tail to tail, it's exactly like it implies. And what you're going to do is you're going to create a parallelogram. Okay, so if I were to create this parallelogram here, oh, okay, draw your V tail to tail. Okay, tail to tail. So this is V, this is U. Okay, and then make a parallelogram. So I'm going to draw my V vector once again. I'm going to draw it right here. Okay, and I'm going to draw my U vector again up here, and I'm going to create a parallelogram. And the resultant is simply going to be, now this way is a little bit more time consuming, and to be honest, the head to tail method is the quickest and probably best way to do it for you to understand, but the resultant would be right here again. And you can see that all I really did was created this triangle up here in the upper half of this parallelogram. Okay, so there's really nothing there's nothing different about this other method. It's just a different way that you can do it, right? Like there's no you're still creating essentially the same triangle that we did in the head to tail method. It's just here you're doing a parallelogram, you're drawing them tail to tail, and just showing you that it's still possible, even if you drew them tail to tail, to still figure out the resultant. Okay, so given two parallel vectors, u and v, okay, parallel vectors, u and v, with opposite directions. So something like this. Okay, so suppose we have a vector going here in this direction, my u, and my v is going in the opposite direction. How would you figure out the resultant, right? Like if you were supposed to draw this head to tail, how could you figure out the resultant? Well, you can draw them head to tail. So imagine I'm doing something like this, and let's see if I can just take a little picture there of that, and I were to move that on top of my other vector, hopefully you see that the resultant is actually right there. That is your resultant vector, okay? And which way is it pointing? Well, I just brought my u vector was larger than my v vector, so this is actually going in this direction like so. So if I were to draw my resultant vector, it would just be this. Okay, so what you do is when you have them going in the opposite directions, to figure out u plus v, okay, so the resultant, so this is essentially the resultant, u plus v. To figure that out is you take your u vector and you subtract it from your v. Okay, so when they're going in the opposite direction, you simply subtract them. Okay, so pretty straightforward idea. So here's some examples, and we'll run through that. So it says draw the resultant vector. No problem. All right, so I'm going to take this and then draw my other one, again, head to tail. So the resultant is simply going to be the addition of these two, which is the full distance here. Okay, so you just draw them head to tail. This is now your resultant. Okay, just adding them head to tail. Pretty straightforward. Going in the opposite direction, just like I had mentioned before, drawing the resultant, if I were to overlay this on top of this, I would have a net displacement going towards the left, right? Because this one here is a bigger vector. So I should be going towards the left here, okay? So if I were to draw my resultant, it would be going in this direction, roughly about that large, okay? Now, if you wanted to see where that came from, simply take, and I'll draw them in different colors so you can really see it. Sorry for the stuttering there. It's just trying to use a ruler on top of my tablet since OneNote can't draw straight lines on my tablet here. So I was trying to use a ruler. Now, if I use a different color, and I now go in the opposite direction for my other vector, you can see that here is my resultant. It's starting from here to there. That's my resultant. It's what's left over after I subtract these two, right? Like this will end up being canceling each other out, and all we'll be left with is a resultant of that. Okay, so hopefully you can envision that and see what I'm talking about there. And certainly it just takes a few practice questions, looking at answers, comparing your answer, and you'll certainly get the hang of it. Okay? All right, so one of the questions in your homework looks like this. So I thought I'd put an example here since I figure I'd probably get quite a few questions regarding it. Okay? Let's label this A, B, C, and D, and we'll put O in the center here. Okay, so now we have, it says to name a vector equivalent to each sum. So if I have AO, so meaning this right here, and my arrow is going in this direction because it's AO, meaning the starting point is at A, and it's going towards O. Plus OC right there. Name a vector that is equivalent to that sum. Well, how about the vector that spans across that entire line there, that entire diagonal? So let's say that it equals AC. And there should be a little vector, okay, arrow above them. Okay, so it just equals AC. Okay, let's erase what we've got, and let's try it again. CD plus DA. So CD plus DA. Okay, so they're drawn head to tail, which is great. Now, again, the resultant is going to be closing off this triangle, but again, you're probably wondering, where do I draw my arrow, right? Is it CA or is it AC? Well, it's CA in this case, because my starting point was here, because it said CD. So my starting point was at C, I went towards D up to A, meaning my resultant starts at C and finishes at A. So this becomes CA. Okay, let's erase this once more. Okay, BD plus DC. So BD plus DC. Okay, hopefully you're getting the hang of this now. The resultant is going to be right there. Which way do I draw my arrow? Downwards, because we started at B. Okay, so my resultant then is BC. Okay. Okay, next example, we're going to determine the magnitude of the resultant vector. Now we're actually dealing with some values here, a 10 and an 8, no problem. Now the only thing is these two vectors are drawn tail to tail, and it won't make a difference, but it will when we find the direction. But let's move this and draw this vector head to tail. So I'm actually going to put it up here as opposed to at the bottom, right? If this is the head, this is the tail, this is the head of this vector, and then this is the tail, and then the head of this vector, right? So what I'm going to do then, nice and neatly, is draw head to tail, and then my resultant is going to go from my starting point to my end point, okay, with an arrow facing my end point there. Okay, so my 8 newtons is here, my 10 is there, and this will be my resultant, and it says find the magnitude of the resultant. What formula do we know? And we assume that this is, again, a right angle triangle. What formula do we know will solve for a right angle triangle if we know 2 of the side lengths? Okay, well, let's call this U, by the way, and let's call that V. We'll just give them some variables there. Hopefully you guessed Pythagorean theorem. Okay, using the letters here. And remember now, R is our hypotenuse, so it must stay on the left there. So we're going to solve for R. U squared is 10 squared plus 8 squared. Okay, and we've got 100 plus 64, so 164, right? And now you're going to square root that. Okay, square root it. Okay, it's going to give you approximately, now I'm going to round to the nearest whole, it's going to give you approximately 13 newtons. Okay, and you expect your hypotenuse to be the largest side, which it is, and rounded to the nearest whole, I got 13, although it was 12 point something. All right, so now remember, a vector can't just have a magnitude, it also has to have a direction. So question B, of course, asks us to find the direction. And what we're going to do is it says to find it relative to u. Now, I drew u right here, which means that relative to u means that I am finding the angle of my resultant with u, with my vector u. So I'm finding that angle there relative to u. If it said relative to v, I would be finding this angle here, but I'm finding u in this case. Okay? So what can we use here in order to do this? If this is my opposite side, it's right angle trigonometry, which means that I can use my primary trig ratios. That's my opposite. This is my adjacent. This is my hypotenuse. If I were to circle, now I need to find theta. Circle what I have given to me and what I need to find. You would see that I circled O and A. So tan theta is opposite over adjacent. Now, we're going to use different variables. Our opposite side is actually our v vector, and our adjacent side is our u vector. So we can find now u over v, which is 8 over 10. Okay, works out nice, decimal of 0.8. Bring tan over because we're finding an angle here, and you get the tan inverse of 0.8. Okay, and what you end up getting is 39 degrees. Now, we have to relate this to one of two ways. We have to state this as either a bearing angle, which remember, a bearing angle is measured from the north, which is exactly what we have here. This 39 degrees is measured from the north, right? Now, you can also say it as a quadrant bearing, where it would be north, right? Starting on the north and then moving 39 degrees towards where? The east. So as a bearing angle, remember, bearing angle has to be 3 digits. So it's 39 degrees, and bearing angles are measured from the north. Or as a quadrant bearing, it would be north 39 degrees towards the east. Okay, because we're going in this direction here. If this is north, east, south, and west. All right, let's do one more problem where this one's going to challenge us for sure the most. We're going to start by drawing a diagram, okay? And we're going to see if we can figure out the resultant here as well as the direction of the resultant. So let's see what we got here. There's a good chance that we are not going to be with a right angle triangle, which means we're going to have to use either cosine law or sine law. So let's see here. Vector u has a magnitude of 30 newtons in the direction 40 degrees. All right, well, I'm going to draw a nice diagram. I'm going to draw my axes. Because remember, we have to measure it 40 degrees from the north. So if this is my north line and I go 40 degrees this way, that is where my vector u will be with a magnitude of 30 newtons. Okay, so that is 40 right there. And that will be 30 newtons, okay, which is a force. And vector v has a magnitude 40 newtons in the direction 100 degrees. Okay, so 100, starting from the north, this is again a bearing angle. Starting from the north, we're going 100. So we're at 0 here, 90 here. So 100 is going to be somewhere just a tiny 10 degrees into this quadrant here, where I'll draw a slightly bigger magnitude of 40 newtons. Okay, so slightly bigger. Okay, so that's my 40. This is going to be, that's altogether from here to here is going to be my 100 degrees. Okay, now, these are drawn tail to tail, which I'm totally good with, right? But if I wanted to draw them head to tail, that shouldn't be a problem either. So if I were to draw this diagram again, just a little bit cleaner now, I'm going to draw my u vector right there, and I'm going to draw my v vector head to tail this time. Okay, slightly larger than my u. So if this is u and this is v, and that's 30 newtons, this is 40 newtons. Okay, my resultant will be right here. But, I mean, you can imagine here that we're going to have an issue figuring out some information here, right? So if I know that this here is 40 degrees, okay, that means everything, if I were to draw a Z pattern, okay, if I were to draw a Z pattern, I would get that this is also 40 degrees. You can see the Z pattern right here. Do you see that kind of sideways Z? So straight down from there would be 40 degrees. Now, that only gives me part of the angle. I still need to figure out this other part. Well, remember that I drew this second, remember that I drew this here at an angle, that my v vector, I drew it at an angle of 100 degrees from the north going this way, right? So if that's 100 degrees, all the way down to this south line would be how much? If I started on the north and I went all the way down to here, how many degrees would that be? It would be 100 or 180, right? A straight line. Okay? That means to figure out just this angle here, if I know that it's 100 to here and then 180 to that line there, to figure out that line there, I would simply do 180 minus 100, okay, which is 80. So this angle here is 80 degrees. Therefore, the large angle that is in here, okay, this is definitely a difficult question here to figure out my angles, is 80 plus 40, which is 120. So let's call that my theta is going to be 80 plus 40, which is 120 degrees. Okay, I now know a side length, a contained angle of 120, and then another side length there. So I am going to use cosine law. I have side angle side, okay? And I'm going to solve for my resultant r. So let's sub everything in. We're going to go r squared equals u squared plus v squared minus 2uv times the cos of, remember it has to match my letter on the left there that I'm solving for, capital R, okay? Or we can just call it theta because we know it's going to be the 120, right? Opposite of my R is my 120 degrees. Okay, so let's throw everything in and see what we come up with. Okay, 30 squared plus 40 squared minus 2 times 30 times 40 times the cos of 120. Okay, and just building on what we did last unit, a cos of 120 is going to be a negative value here, so be prepared for that. We're in quadrant 2 there, where any cosine ratio will be negative. Okay, and now let's work this all out here. We've got 30 squared plus 40 squared is 2,500. Okay, bring down your minus sign. Okay, and you get 2 times 30 times 40 times the cos of 120, which is negative 1,200. You now have a double negative situation where you are going to add those two numbers together right there. So 25 plus 1200 is 3700. Now take the square root on both sides. Okay, and you get a resultant rounded to the nearest whole of 61 newtons. Okay, but we know we're not done here. If this is a vector, we always have to give direction. So it says determine the direction of the resultant vector. Okay, so if this is my triangle here, that's U, this is V, and here's my R. And I now know that my R is now 61 newtons. And I know that my U is 30 newtons, and that's 40. And I even know that this is 120 degrees. If I were to find my resultant, it's going in this direction. Now watch. What I need to find is a bearing angle from the north. So I need to find this plus this to figure out my resultant angle. Okay? So this I know was 40 degrees. They gave that to me in the question. They said that the vector u is 40 degrees to the north from the north. Okay, a bearing angle from the north. So I know that that's 40. All I need to do is find theta here, and I will add it to 40 in order to get my resultant bearing angle. Okay, but let's find theta first. And to find theta, I mean, we can probably use the sine law. We could use cosine law as well because we have all three side lengths. But sine law is a little bit quicker. So let's go, we have angle, opposite side, angle, opposite side. Okay, so let's set this up. We are going to use V over sine capital V, this will now be capital V, equals R over sine capital R, which is our 120. And so we have 40 over the sine of V is equal to 61 over the sine of 120. Okay, cross multiply. All right, so you end up getting 61 times sine of V is equal to 40 times the sine of 120. All right, divide both sides by 61 and then take the sine inverse. So what you end up getting, and I'll write it all as one step here, is the sine inverse of 40 times sine 120 divided by 61. Okay, and what you end up getting as an angle there is only 35 degrees, right? But that is not our bearing angle, right? That is not our bearing angle. We've got to add it to 40 now because the bearing angle is measured from the north. So give me a therefore. Is 40 plus 35, which is 75 degrees. Okay, and actually it has to be stated with 3 digits, so make sure you put a 0 out in front. You could also state it as a quadrant bearing of north 75 degrees east, same thing. Okay, so that was one of the harder examples of how to calculate resultant vectors. Okay, so in this case, we had an example where there were forces acting in different directions, and then we had to calculate the resultant force acting at the end of our vectors there. Okay, and we just use our trigonometry knowledge of Pythagorean theorem. In this case, it was cosine law, then sine law. Okay, we can use the primary trig ratios, sine, cos, or tan, just like we did here. Okay, it all deals with triangles. All right, so that concludes adding vectors. Our next lesson will be subtracting vectors.